Hey everyone, welcome back. I hope you guys are doing pretty well. So we will see today's daily challenge on Leetcode and we will try to solve it together. And so today's challenge is a medium hard kind of problem. So maximum dot product of two subsequences. You are given two arrays nums1 and nums2. Return the maximum dot product between non-empty subsequences of nums1 and nums2 with the same length. Okay. The subsequence of an array is a new array it can be formed from the original array by deleting some or none of the characters without disturbing the relative positions of the remaining characters. So the definition of subsequences is told you need to select two equal length subsequence from the array and find its dot product, and out of all such possibilities, whichever gives you the maximum dot product, you need to return the value of that maximum dot product. Okay, so I hope you know already what a subsequence means. That is, the numbers which you are selecting must be in order from the array, but may not be consecutive also. Okay, so 2 3 5 is a subsequence, 1 3 5 is also a subsequence, uh, talking about this array. But if you talk about 2 5 3 or 1 3 5 1 5 3, they are not subsequence, because 1 3 5 is subsequence. The relative order matters. Okay, so yeah, I hope those things you know already. And see, as you can find in this example, is that if you take this subsequence 2 comma minus 2 from the first array, this subsequence is of length 2, and if you take another subsequence, let's say 3 comma minus 6, and multiply both of them, find dot product means multiply the corresponding elements from both of the arrays. So 2 into 3 plus minus 2 into minus 6, that gives you total. If you add all of them, it gives you a total of 18. Okay, so turns out that this would be the maximum possible value of the dot product. Okay, so the length constraint are like 500, so you need to find a solution. Yeah, so how to approach this problem? By looking at the problem, you can easily think that uh, what can I do? I can do take not take within this whole array. Okay, so for every element I go through this array, I can just choose to take or not take. For every element I go through this array, I can choose to again take or not take, and I will just maximize my answer. Okay, so this, by looking at the problem only, you can just think that it is a take not take simple kind of DP. So yeah, not much difficult problem this is, although this is marked hard, but not much difficult. We will see how to solve from recursive solution to memoized. Okay, so if you do not know already how to convert it, I have my DB playlist where I'm teaching DP from scratch. Yeah, I will be also putting more videos. Just have patience. Okay, so I'm not getting much time as of now, but yeah, if you can follow the first 3 or 4 videos of that playlist as of now, you can easily understand how to convert recursion to memoization and also to iteration kind of DP. But only the iteration memoization steps completely gives you an accepted solution, so we will quickly see on this. And yeah, so what can be the possible cases? So you can see the thing which I was talking about is that you have one array. Okay, this array you are having. Okay, and let's say your I pointer is pointing to some element in this array, and you have, let's say, another array and some j pointer is pointing to that. So let's say this is array 1, this is array 2. Okay, so I pointer and j pointer you are having. What you can do, see, you can choose to take or skip this element. Okay, or you can also choose to take or skip this element. What happens if you take both of them? Then if you take both of them, see, there is a possibility that you can multiply them only. So nums I multiplied by nums j. Okay, and you can add this to your product. Okay, so you can choose to take these two elements. This is one possibility. Okay, so I will tell that this is one possibility. Another possibility is that we have two more possibilities. So another possibility will be that skip ith one. Okay, so you choose not to take this element and move forward. That is also a possibility. And another possibility being that skip the jth one. Okay, so in two successive decisions, if you choose to skip the ith one as well as the jth one, then you will it is equivalent that in one decision you are skipping both of them. Okay, so you do not need to take care of a separate case, fourth case, where you just skip the ith and the jth one both together, because one by one decisions also you can take, no problem with that. So if you choose to skip the jth one, that is another possibility. So at first you can write a function, a function which is a recursive one, and you can pass the two arrays and 0 0, meaning that this is a value of I, this is a value of j, and both of them starts with 0 initially, and one by one we can go together. Okay, so if I'm skipping the I, what I will write? Function a1 a2. Let's say I'm skipping the I will write I plus 1 j. Okay, as I am skipping the value of I. If I am skipping the value of j, I can write a1 a2 I j plus 1. And what I am doing, another possibility is that if I am taking these both values, so I will have to do I plus 1 j plus 1, right? Because I and j both values I have already taken, and with that I will add this product. So if this is the product, I will add this product to my answer. Okay, but yeah, there might be some exceptional cases that you will see, and yeah, the overall intuition looks as simple as that. We can simply write a recursive solution, start by writing a recursive solution, and then memoize it to convert it into a recursive DP, what we call it, memoization solution or recursive DP. Yeah, so that we do not repeat the states of the recursion basically. So we'll see how that happens. So first of all, it's very easy, is that I will simply write the recursive function. So function, I will write one function. It will take these two arrays, nums1, nums2, and it will take 0 0, because I and j initially these two values are 0. Okay, and this function will return an integer type, because it wants to return the maximum value of whatever that is asked, the dot product, right? So yeah, we will also calculate the dot products on the fly. So we have this nums1, nums2, and also we have int I and int j. Okay, so yeah, we have both of them, and we can write n and m, which is nothing but nums1 dot size, n is nothing but nums2 dot size. So now what if any one of I and j tends to exceed this value of num? So if I is greater than equals to n, or j is greater than equals to m, so it basically means that you are reaching the end of the array. So if even one of them reach the end of the array, definitely you cannot choose to just traverse. Okay, so yeah, there would be a case where that array is not reaching, and you might be thinking that, hey, if one pointer is reaching the end of the array, why not traverse the other pointer which has not yet reached the end of the array? But you see, there will be some decision where I do not make that pointer reach the end, but the a2 pointer I can reach the end. So let's say when this I pointer is just before the end, I can choose to not move that, and only skip this a2. Okay, in that case we will take easily, so you do not need to overthink on that. Okay, so what I need to do, what do you think we will need to return? See, function is there. What does this function return? Function tries to maximize some value, right? So definitely we can try return int min or something like 1 minus 1e9. Okay, yeah, so I hope you would have understood this. This is not much difficult. Okay, so what are the cases which I thought? Take both of them, not take individually for both the arrays, right? But take what that will give me three choices. Take both of them, skip one, and skip the second one. Okay, so I will have something like take both, skip first, okay, and I will also have something like skip second. Okay, so we'll have this, and if I choosing to take both the elements, what will be it? It will be nums I multiplied by nums j plus function of nums1, nums2, I, and as well as j. Okay, so not ij, I plus 1, j plus 1, because we have already taken this element, and if we are choosing to skip some element, it's more simpler. We don't have anything to multiply right now with us. What will happen is that if you are choosing to skip the first one, I will do I plus 1 j, and if I'm choosing to skip the second one, will be simply ij plus 1. Okay, so yeah, I hope it is very simple, and you can simply choose to return what you know, maximum of all of them, because you need out of all the possibilities, whichever will be giving me the maximum one, I will backtrace that one only, so skip second. Okay, so we have this, and one thing you must take care. Okay, one thing which is that one edge case is there which might result in a wrong answer. uh, you see, this is giving you a maximum of these three values, right? Okay, this is giving returning a -1e9. Okay. Now suppose this whole function returns a negative value. Okay, the function which I highlighted, listen carefully. Let's say this whole function returns a negative value. Okay, and this product is a positive value, then you are actually reducing that positive value. Okay, because negative value the function is returning, and this uh, product is a positive. But you see, don't you think we must clip this negative value to 0? Because uh, let's say you are in the ith position of this, giving you a number which is a positive, whatever number is the product is, let's say this number is a b, this is nothing but nums I and nums j, product a b. Okay, talking of the first term is positive, but talking of the next term is negative. Okay, so it is reducing the value, so this value may not even be captured. But one thing you can always do, is that out of the whole array you select just single this element and single this element and return ab. So it may be possible that you are never capturing this ab in your answer. It's always ab minus something. Let's say this always returns negative afterwards, so it's always ab minus something, and you are never able to capture ab. In other words, we choose to clip this value to 0. I will also explain you in a different manner. Okay, what is that different manner? You see, uh, this is like introducing a fourth case. Okay, still now we have taken three cases, right? Okay, this is like introducing a fourth case. What is that fourth case? Start afresh. What did I just speak? Okay, so here what you are doing, you are selecting the ith and jth element and adding that product. You are skipping the ith element, you are skipping the jth element. But one thing you can do, select the I and j element, do not add this to the product. Let's say your product, the remaining product is negative, and the ith and jth element, this product is positive. So you can also choose to start afresh, that is delete all my previous considerations. Let's say I have done take, not take, not take, whatever the previous values which I have taken or which I am going to take, that those things I am choosing to start afresh from these two elements. Okay, I am telling that, hey, select these two elements separately since they give a positive product, and if you are trying to reduce that product, start afresh. Okay, so this only tells you that see, when this will be negative, when this function will be negative, you will be starting afresh. This whole max value will have no value. Okay, this whole thing will have just 0. So you are in take both case, you are just starting afresh from that. Okay, so yeah, I hope you did get some idea of what I'm trying to say. If I try to run this, let's see if it works. Uh, okay, so this is nums1 and nums2 which I forgot to write. Okay, did anywhere else I forgot? Let's try to run and check. Yeah, you see we have the accepted case, but quite obviously since this is a recursive solution, it has an exponential time complexity. At every step we are taking 3 decisions. Okay, 4 decisions effectively max of this, so we will definitely get a TLE. Okay, because of the recursion branch, and as I had told you, you can easily convert this to a recursive DP by initializing the DP. So you have it to be something like 500, right? So I will choose the DP to be 501 for easier syntax. I'm just doing it, and I will initialize all elements of the DP with -1. So name set DP -1 size of DP. Okay, so you have it, and -1 represents the empty cell in the DP. So if DP ij, okay, if this ij is not -1, what do you need to do? It tells you that hey, this cell is already filled, so you do not need to fill it again. In this way, what you are doing essentially is skipping the computations which you have done already. Okay, so this helps you to reduce the time complexity. And what you can do, dpij to be simply as, take this whole thing, okay, dpij, so you have this. So I guess this should just work fine. I have explained in detail. It is like a cache memory. So this dp is like a cache memory where I store the values. Okay, every time when I, after calculation, I store the values and I avoid calculating the values again. That is, I avoid revisiting the states. Okay, if I am revisiting, just return directly the value. I have explained in detail in this thing about in my DP playlist, and I hope you do understand this cache memory concept. This is known as memoization. You can also write an iterative DP. Okay, so yeah, we are getting an okayish runtime and a good memory complexity. If you see this, I have initialized to 500, but this may not always be 500. See, in meme set, this is traversing through all those 500 cross 500. Okay, so what you can do, what I will give you to do, I'm not doing that. You can take a dynamic vector of vector. You can create a, instead of initializing all the elements 500 plus 500, so the array size may also be like 10 cross 15, right? So why will you initialize 500 cross 500 in such a case? So you take n cross n and m, where n is the size of this, m is the size of this, and you create a vector of vectors in 2D array, and you pass that in your function. You pass that dp element in your function like this, and you remember to pass it here and here, and the remaining code will just be same, and you can just try it out. Your time complexity might reduce a little bit. Yeah, apart from that, you can also go ahead and trying the iterative solution. A detailed explanation of how to convert a recursive solution directly to an iterative one can be found in my DB playlist again. So yeah, that's all. I guess that's all for this video. It gives an accepted solution anyways, and if you analyze the runtime complexity, it is also not much. It will be O of m into n. So yeah, that's all for this video. I will meet you in the next video. Till then, thanks a lot.